I'm just going to talk about the research that I've done for the past 3 years on eye tracking. I don't want to poke myself in the eye, so I'm going to sign one sign for eye tracking. I have worked with 2 postdocs, So-Won Huang and Adam Stone. Both are deaf. I got funding from VL2 at Gallaudet to support these 2 positions. First, I want to show you the pictures to introduce our eyes. Just take a second to read the quote. Just one connection can be made. A connection can be made by one glance of the eyes, and it means a lot. Often we say a lot of things, and we can lie sometimes, but the eyes just automatically show what you're thinking, your internal desires, your emotions. And it only takes a second. And with the right equipment, you can measure that eye movement. We can learn 2 things from gaze behavior. Oh, are there? There's headset. Oh, here. It's not. I'll take your mic, this one. Okay. I'll try to talk louder. Can you hear me now? Is that better? Is that better? Yes? You can hear. Is it louder? Is it loud enough? Okay. Okay, so 2 things we can learn about human cognition from gaze behavior. We can learn about stimulus-driven activity, things that come up in our line of sight that we draw attention to. And we also make decisions on what we look at depending on our desires. So both factors we can gain more information about. These are my 4 goals for my talk today. I'll first introduce you to what we have already known about gaze behavior. I'll talk about eye tracking measurement and research questions. I will talk about my 4 eye tracking studies and then some brief discussion. Please feel free to interrupt and ask questions as I go. And if something isn't clear, please ask. I did plan time for people to interrupt and ask questions if needed. So we know a lot of information about what our eyes do when we read. There's about 60 years of research on eye tracking while reading. You notice that right in the center of the image on the left, the center is very clear. And we are looking into whether our eye behavior is the same while reading frozen text as when we're reading sign language. So we're looking into what our eyes do when we watch sign language. Do they move the same as they do when we're looking at frozen text? So that's what we're looking into. We're looking into what the eyes do when the stimulus is moving or when the stimulus is static. So this is what your eyes do when you read. And I'm sure you assume that you're looking at the whole page and your eyes are moving smoothly across a line of text. But we do have the technology to record where your eyes are looking while you read. And actually, what your eyes do is hop from word and maybe skip a word. And the yellow circles you see on the text right now are fixation points. It's where your eyes stop and look briefly. It might only be for 40 milliseconds. And a millisecond is 1/1000th of a second. And so if you imagine that, you might stop on a word for 20 to 40 milliseconds. A jump from one word to the next is called a saccade, and that happens very quickly. Think about a gazelle running in Africa. They might move 70 meters in 1 millisecond. So your eyes move very quickly across a line of text. An expert reader, I'm going to explain what that looks like. So for people who read well, they might just bounce across a line of text a couple times, which means that they're reading quickly. A child would look at each word individually. And adults don't do that. Adults do not stop and look at each word. Adults also have a larger peripheral view. It's, let me spell it for you. It's perceptual span. So adults are actually looking more to the right. So their perceptual span is wider to the right because of the way English is read. So it's about 15 letters wider to the right. But the language you read impacts your perceptual span. For example, if you're reading Hebrew, which moves in the opposite direction, your perceptual span is going to be open wider to the left. So just think about that. You don't just read the word that you're focused on. You read to one direction or the next. Suppose you were reading a line of text and you come to a word that you don't know. You may need to take more time. And so we can tell if someone is stuck on a word. And we use that as a way to measure language knowledge. If they're novice language users or readers, they're going to spend more time on each word. I'm giving you a bunch of facts right now, but I want to tell you one more thing. I remember reading chemistry. I would get to a word and not understand. I would go back and read that line again. Very complicated topic. That's called regression. It means going back and rereading. So that's behavior that does not happen if you're an expert reader. If you're a novice, you tend to regress more often. We have a lot of research about our eye tracking during reading, but watching sign language is my research and trying to figure out what the eyes do during sign language watching. First, I want to talk about the word watching. I'm not confident that watching is the right word. The title of my talk uses the word read in quotes, and I am not confident that read is the right word either. But to use the word watch, I feel like we're watching TV, but that's not the same kind of watch I want to use when we're watching sign language. The point is, what we watch influences, and what our eyes do influences whether or not we're comprehending. So when you're doing sign watching, you're looking at people's faces. There's a lot of research published that proves that. So you see signers in the pictures up here, and they're looking at each other's faces. People disagree on where exactly we look at the face. Some research shows that people look at the nose. I don't necessarily believe that's true. Some people look back and forth between eyes. So just think for a minute, where do you think you look when you're watching somebody sign? I know you're all talking about it now and thinking about where you look, but I have one more thing. A lot of research has happened here. And there's been a lot of research about eye tracking done here at RIT, but that research has been done in the classroom. And it shows where the student is looking, because there are a lot of things competing for your attention: the interpreter, the screen, the teacher. So that is more of a pressure to look between all of the different information that's coming in and trying to balance all of that visual information, because you're looking to do the best work that you can do in the classroom, because the students are looking to get an A, and so that also influences where they're going to look. The student would be wearing technology that monitors where their eyes are looking during an everyday situation as they move along in their life. They're also conscious of being tracked, so they're making sure that their eye gaze is appropriate. But in the classroom, there are competing visual stimuli to look at, and you want to make sure that you're looking in the right place. But there's also that pressure to comprehend. So I use video, because there are no pressures to make sure that you're looking in the right place, to make sure your eyes are behaving appropriately. The only goal is to comprehend the message. It's really important for us to understand different contexts, but for the purpose of my study, we used video.
Okay, I'm actually a visual scientist by training. And so I understand a little bit more about visual perception. So I want to give you some information about that. If you look in the center, the smallest circle, I think it's the size of maybe 4 or 5 letters, actual characters. That's called the foveal, and that's the center where the most clear vision is. It's a very small space. And then if you look at that next circle, you have okay vision. And I'll show you what that'll all look like. And it gets more and more poor as you go out from the foveal. So when we're signing, our hands aren't signing right in that center space. They're signing all over. I mean, they can be up in the front of your face, but for most people, you're signing down farther away, where your vision is most poor. And I measured where the hands typically are during random choices of signs. And this is the yellow dots are the positions of the hands during signing. About 80% of the time, the hands are below the chin. You know, so if you think of the foveal area as the mouth and nose area, then you have a reason when someone's signing to look down into a more blurry place. Now, this is what it looks like. The top is that small section. It's very clear in good focus. You can see that photo clearly. And then if you go out one level, you're about 4 times more blurry. And then if you go into the farthest level, the peripheral level, it's 12 times blurrier than the most clear. And we don't really realize that because our brain fills in the blanks for us, but the vision there is actually quite blurry. So there's some, that leads to an important empirical question. there's a good reason to look down if you don't understand a sign. So that's one of our big research questions, and how we can use eye tracking technology. And also how watching signing is different than reading. It's a big puzzle in the field of psychology. So we're going to go on now to the next part, and I'm briefly going to give you some of my research goals and methods. It's really hard to see up there on that left screen, but there are little dots, and each dot is a fixation point of the eyes. Every 8 milliseconds, approximately. And then on the right is a heat map. You know, like if you see a storm coming, the red part is where the most activity is. It's the same concept. The red part is where the eyes are lingering the longest and the most. So my research interests lie in where viewers are looking, how long they're looking in those places before they move on to the next fixation point. Maybe one thing is more attractive for them to look at than another thing. And then how focused or scattered their viewing is, if they're looking in one spot continuously or all over the place. Do we have any questions so far? No? Everybody ready to move on? Okay. So I've done 4 projects related to this. These are the first 2. And they both relate to infants and babies. And these are babies who can hear, that do not know sign language. So those are important parameters. These are non-signing babies. First of all, we know all babies are born ready for language. They're ready to learn. They're hungry and they're searching for language. They have like language radar, right? They can find where language is and they're attracted to that. It doesn't matter where you're born. You can, if you're born in France, you learn French. If you're born in America, you learn English. If your parents speak 4 languages, then you can learn 4 languages. If your parents learn ASL, then the baby learns ASL, right? That's pretty clear for people. Because babies have high sensitivity, hypersensitivity to languages in their immediate vicinity. So the question is, do non-signing babies know that sign language is a language and are they attracted to it? And if they are, what causes that? So I'll give you an example. Oh, so if I showed that to a baby, that series of movements, would they be able to tell the difference between what are signs and what are not? Just gestures compared with actual established signs. So those are the first 2. And then there are 2 more. And remember, these are first 2 are about non-signing babies. And the second 2 are about how signers reflect eye behavior. People who have experience with sign language. So we use children and adults in these studies. And I talk about adults first because it's important to know the measure at a base level and then how we can backtrack to children and what that looks like. A mature level first, and then we'll go down to the child level. Okay, so we just have a little bit of information about each of these. So this is the first project that we did. It was very simple. We showed babies a variety of gestures, like body grooming gestures, as well as a variety of signs. So we go from gestures to signs and back and forth. And there was a lack of affect on the face purposefully. There was no facial expression in the signs. So we showed these a variety of times alternating. So we showed them across all gestures and the signs. so we could see what they looked like. And then we measured where the babies were looking. So now I'll show you a real baby doing the real experiment in. So this is the baby, the picture of the baby, and the red dots are where the baby was looking. Okay, so that was the method that we used. We used different videos, but that was just how we measured the baby's eyes. So we showed babies signs as well as gestures, and we wanted to know which they looked at more. Here are results over on the right. Oh yes, the ages too are important. So we had two groups. We had babies who were 6 months old, and then a group of babies who were a year old. And there was a big difference in the results. The younger babies, the 6 months old babies, preferred to look at the signs and didn't look as much at the gestures. But the reverse was true for the babies who were 1 year old. The 1 year olds preferred to focus on the gestures more than the actual signs. And remember, these are hearing babies who have had no contact with sign language before. So maybe some of you have taken a psych class. You're familiar with the concept of something that we call critical period. Yeah, this is kind of an important part. Does anybody know what a critical period is? Have you heard that term before? A few people have. Okay, great. So the critical period is really important. It's a very hot topic right now because when babies are born deaf, we want to expose them to language early, right? These babies at 6 months old were ready. They were ready to acquire that language, even though it was sign language. They knew, they could tell that it was a sign, and they would focus on it. But by the time that they were 1, that tendency was gone. So we'll talk about this a little bit more later and what the implications of this are. Okay, a little bit of linguistics. If we have any linguistics people, I love linguistics and math. So we played with linguistic theory and tried to explore why babies were attracted to language in general, both spoken languages as well as sign languages. Like I told you before, babies love language. We all know this, especially we know about spoken language. So now we'll show baby love sign language. We didn't know that, but let me tell you a little bit of a story. So my friend was on an airplane, and there was a baby next to them screaming. And so finally my friend started signing to the baby, and they were in awe, and they quieted right down. I mean, it was a 6-month-old baby, right? So the point being that all babies can learn sign language. So there is something in the signal, in the spoken and sign stimulus. And we're trying to figure out what cues are there. What cues are in both of these language modalities. Babies like both signed languages and spoken languages, so we did find one cue that is in both of them. It's very difficult to fingerspell, but this is the sign that I use for sonority. I'll give you a brief overview, but it's a perceptual quality, a perceptual property, right? For things that are bright or loud. But it's more than that. It's also oscillation. Brightness, oscillation of brightness, or oscillation of volume and loudness. And that's the foundation of making syllables, right? It's the different sounds, the different movements of your mouth that make those syllables. And the same thing is true in sign language. Some words have more high sonority, like the word day, for example. We can exploit sonority as well. If we're doing more performance, we can add bigger movements, like a mother talking, you can see this oscillation, you can see these movements. And so that's the same in sign language and in spoken language. Some signs are have less sonority, like this sign. It's kind of harder to see. It's more of a quiet sign. The movements are smaller. So we have high and low sonority in our words. Right? So the sign for day is a high sonority word. So Adam Stone's idea was that maybe the sonority in spoken and sign languages, so we decided to test that. And I'll show you this book. This book has math theories that explain what makes a word, what gives it high or low sonority. It's all math. Fingerspelling also includes sonority. And it's nice to use fingerspelling because if you're making these large exaggerated signs, babies might like it just because it's big. And it wouldn't actually be about the language quality. So that's a bit of a problem for testing and trying to test these hypotheses. That won't work because it could confound the research. Or if I use a sign with low sonority, but I do it faster, that becomes more sonorous. So maybe babies just like that. So again, that could confound our data. So we decided to go with fingerspelling. It's contained, it's smaller, there's a space envelope there. You can manipulate the sonority with fingerspelling. So it's really fascinating to test this hypothesis. So I'll show you an example. When we fingerspell, maybe for the first time, we spell each letter, B-A-C-K. Like if I say the word cat, I say the k sound, a, t. So I say each letter, and we don't really do that in spoken language. We put them together to make the word cat. So you put each letter together to make the full word. The same thing happens in fingerspelling. You don't wait with the B, A, C, K. That's not how we do it. It all comes together to become the word back. And you still know what I'm saying, even though it's a little bit sloppy. But I follow our pre-established rules, our implicit language rules on how we fingerspell well. No one told us how to do this, but we all have that knowledge about how language works. So I can drop some letters and you still understand what I'm saying. It's not random. I don't just make up the rules. There's a consistent way that fingerspelled words become something that we call lexicalized. Like each individual letter becomes a word that is spelled. So again, one more thing for fingerspelling. You might feel like there's one solid movement. It becomes one unit. It becomes a word instead of a combination of individual letters. It just becomes one fluid movement. Okay, has everybody had a chance to read this? Great, so this is when we were ready to test our hypothesis about babies' sensitivity to the properties of sonority. So I'll show you what this looks like. If you take a word, this is a real word. It's a pretty rarely used word. And we use that yellow book that I showed before to make a well-formed fingerspelled word. And then we broke the rules and made a poorly formed word. We did not decide what it would look like ourselves. Well, we kind of did, but we did follow the mathematical equations to make sure we were following what we needed to do so that native adult signers would understand a well-formed word. You know, we didn't tell them why were we asked to know. We just asked them if they understood or not. For adults, that was. We just asked them if they understood the word. So adults who were expert signers validated that our words were well-formed and ill-formed. Okay. So it's kind of jerky because of the loop, but they're both on the loop. So they both have that little bit of jerkiness. It's a little bit subtle, but if you're testing adults who are native signers, they agree that the one on the left is better. And sometimes they don't know why or think they might just be guessing, but they agree that that one is well formed. And I can show you again if you want, but we noticed that the well formed have more of a fluid movement. And then the ill-formed one have more internal jerky movements. The well-formed have more sonorous movements.
So anyways, we showed many different words to babies, well-formed and ill-formed versions. And you can see that the baby's looking back and forth between the hands. So first, you can see which hand or which form the baby focused on. And these are babies who have not been exposed to any sign language, and they are more attracted to the well-formed sign. And when they're one, they don't have that preference anymore. They can't tell the difference. So if they're not exposed to sign language, they lose that hypersensitivity. But the 6-month-old infants are hypersensitive to the cues in the stimulus. They're ready to learn that language. A hot word in research right now is modality. Now, when you see up there, I have the word amodal. That's another hot word in research. It means that it doesn't matter whether it's spoken language or signed language. It means that babies can learn any language. It just depends on their exposure. Sonority is also important here because if it's missing, if one cue is missing, it can influence whether or not a baby is attracted to that language. Okay, any questions? At the end, I will clear some up. But now I would like to focus on the last 2 studies that I have done. This is tested on adults and children who are familiar with sign language. And this is what we expect to see from native signers. And we'll also compare what we know in adults to children. So we tested 2 groups of signers. These are all signing adults. One group are novice signers who have taken a few sign classes. They're hearing, all of them. They're about 25 years old. The other group of adults have been signing since birth. We did test other groups of people, but for comparison, we're talking about novice hearing signers and native signers, comparing what their eyes do while they're watching an ASL story. And that's all. It's quite simple. But what I tell the people in the instructions is that they come into my lab and they're going to watch a story, and that I'm going to test their comprehension of the story. And so the people are really paying attention to make sure they catch all the details. And the novice signers are really trying hard to comprehend everything. But the native signers are like, well, this is really easy, of course. So I would like to involve all of you. So you need to tell me, you need to guess who you're watching, whether this person is native or novice. Okay, let me show you the second one now. Okay. What do you think? This is native? Raise your hand if you think the one on the right is native. What's the difference? Anybody want to volunteer to explain what they believe is the difference? What's the difference in the red dots? It's a recording of a person who is a native signer and a person who is a novice signer. What happens with the red dots? Oh, she's saying one is looking all around and the other is looking in one place only. I mean, I didn't really know what to expect, but the native signers are looking in a very small place. They don't tend to look around. The novice look around the screen more than a native. Now, remember the story that I just showed you. It was very simple. But what happens when the story is hard to understand? And remember, we talked about reading. You might focus on a specific word a little bit longer. So we came up with a hypothesis of how the eye gaze would appear different if the story was difficult to understand. Do you understand that? Kind of? You do? What was wrong with it? There's something wrong with it. Any other comments? Yes, so do you understand why this one is different? Okay, I will tell you. This one is in reverse. It's being shown while being rewound. So Do you understand a little bit of it, maybe? Okay, so now this other version is the same story. Okay, so the empirical question we came up with is how does that impact eye gaze? So we tested a couple of groups of people again, novice and native signers. So are you ready for the results? I'm first going to show you the results for the native signers. Their eye gaze is mostly on the face, around the mouth. It's possible because there's a lot of affect on our faces. And that's what we call the gold standard. The top left picture is the same image you just saw. But now we're going to see what happens with novice signers. Oh, actually, that's not. So the graph on the right shows where native signers look when the video is reversed. And it's actually very similar, which means that native signers don't change their behavior if the story is complicated. They're still looking in the same place. And I think that it's because the perceptual strategies of perceiving language are already learned. It's like riding a bike. If it's a flat surface, you know what to do. If it's bumpy, you know what to do because you already have developed that skill. Now for the novice signers. You can see that the area in green is a little bit wider. And then when the video is reversed, it's even more so. So novice signers for the reversed video are looking more between the forehead and the waist, whereas native signers are still concentrating on the face. We had about 15 people in each group, and these are the averages. Okay, now what happens with children? Before I move on, does anybody have any questions about this? Is this all clear information? Are they deaf or hearing? So the native signers are deaf. And the novice signers are hearing. I think that is an important factor. There is other data that we have that includes what happens when young hearing people learn language. Their results are comparable to the native signers. Now, children. We recruited hearing children, CODAs, with the average age of 5. Those children came into my lab to watch the Little Red Riding Hood story. They also watched Cinderella, the Goldilocks. It's, well-known, loved stories. I wasn't testing the children's comprehension of sign language, but these are children who have parents at home, deaf parents who use sign language. And so these hearing children are emerging signers. That's one group who came in to view the stories. The other group of children are children who have no knowledge of sign language. So if you look at this picture here, this child is wearing a cochlear implant, but was not using it during this study. Do we understand so far? So this is a very simple test, just for the children to watch the story and understand where they're looking. The hearing children with no knowledge of sign language, I had to explain to them a little bit more about what they were expected to do. I said to them, you're going to watch a woman on this movie who is using sign language, and she's talking about Cinderella. So I want you to use your imagination. So here is one child's reaction. Is a hearing child with no knowledge of sign language, and they don't really know what they're looking at. And I just said, you know, I know you don't understand, but would just try and watch and use your imagination. So they were looking for visual and physical properties, and without that, they really didn't have any engagement. They didn't understand anything. Now, with the CODA children, they were looking for new words, and they were trying to understand the story because it's something they're capable of doing. So those are the differences in the groups. Now, the results. These are the results from the group of CODA children. These are the CODAs, and they're focusing in a very small area of the face. There were 15 CODAs in the group, and there were 20 non-signing hearing children. So the shape is very similar, the shape of the data is very similar, but the non-signing children tend to explore the entire screen. Now, interestingly, the signing children have very similar results to those deaf native signing adults. The CODA's average age was 5, and so they ranged from age 2 to 7, but honestly, the 2-year-olds did not show any difference from the 7-year-olds. Their data results were very comparable to the signing adult results. They focused on the face at a very young age. Okay, so I know that's a lot of information, but I try to usually sum up my talks in 3 points, something that you can take away easily. Now, all babies, not just deaf babies, but all babies have the potential to learn sign language at between 0 and 6 months of age. If they're not exposed to the stimulus, then that ability is lost. Eye tracking can give us a lot of information about babies or adults' experience with language. We can tell if they're native or novice. All I need to do is invite someone to the lab and secretly record what their eyes are doing, and I can tell. It's almost like a lie detector test. Experience impacts children. The earlier they're exposed, the better they acquire the skills. Now, I didn't test deaf children. Not yet, anyways. But now this is sad because we know that most deaf children are not exposed to sign language before 6 months of age. Exposure is required. So my postdoc, Adam Stone, is working on his dissertation currently with the VL2. And he is showing a powerful connection. Remember the fingerspelling sonority? And so he's finding a connection between fingerspelling sonority and reading skills later in life. So we think that babies don't understand fingerspelling, but they do. Hearing people who are not familiar with sign language believe that fingerspelling is just borrowing an English word, but it is an important input for the babies as well, and for language exposure.
Yay, yay. Okay. So first, I would want to let you know that I would welcome your feedback, any thoughts that you have. I would love to hear your feedback. Maybe give me some new directions for my research.